Okay, let's get started. So my name is Emilia Moreno. Welcome everyone. I'm the Deputy Director of the ecoinvent Association, and I will be hosting this webinar for you today. Just some instructions before we start. We are recording the webinar. We will post the recordings in our YouTube channel, so you will receive a notification when this is done, when the recordings are posted. You will also receive the slides of the webinar. You have realized you are all muted, so if you want to make questions during the webinar, please type them on the question pane, question section in the GoToWebinar app. As I have said, and as you can see, I'm alone today in the webinar, so I will be stopping and looking at the questions and trying to answer them while I speak. If for whatever reason your question is not answered during the webinar, I will make sure that you receive an answer via email later on. So that said, let's start by introducing the structure of the webinar today. We will be discussing today, I will first give an introduction to the association and the ecoinvent database. We have some newcomers to the database. I think they will appreciate that. And then I will dive into ecoinvent 371, starting by explaining why do we have a 371, and then the details on the content of 37 and 371. So let's start with a quick introduction. Who are we? What is the ecoinvent Association? So we are a non-for-profit organization that was founded in the late 90s by 5 Swiss research institutes and federal institutions. We are a team of around 20 people. And most of us, we are technical experts with an expertise in LCI and LCA, but we also have IT specialists, a sales team, and a communication team. What are our activities? Well, the one you know us best for, of course, relates to the ecoinvent database. We manage, we maintain, we publish, and we sell the ecoinvent database, but that's not the only thing we do. We also participate in other projects. We participate in projects when they are aligned with our mission. Our mission being to promote the use and the good practices on life cycle inventory. So we participate in projects and to with the aim of improving data availability and quality. We have participated in several projects, like, for example, SRI, Sustainable Recycling Industry project, where we were supporting stakeholders in the collection, but also in hosting and publishing lifecycle inventory data, or in creating tools for lifecycle inventory creation and in hosting those tools. We also participate in projects such as an initiative such as PEV and GLAD, where they are in this crossroad between giving access to data and improving interoperability between formats. We work in the PEV initiative as data providers, but also in different working groups and boards in the initiative. The ecoinvent database is a global lifecycle inventory database. It contains more than 17,000 datasets for more than 3,000 products. The datasets represent around 140 countries, and we ensure a new release every year. Where is this data coming from? The data that enriches the ecoinvent database comes from all Estamenta. It comes from data providers that are in the industry or industry associations. It comes from research institutions and universities, from consultants, and even from governmental agencies in some cases. Before before publishing the data in the ecoinvent database, it goes through internal review for compliancy and consistency, and it goes through an external review by a competent body of editors, which is called the editorial board, and it's composed of experts in the different sectors, in the different fields that the database covers. Around the database and the database methodology, we organize user support, training, capacity building, such as this webinar and other webinars that you can look at in the recordings in our YouTube channel that I was mentioning before. A quick introduction on the content of the database. The database covers all kinds of human activities. As you can see here in the image, it covers from crop production in the agricultural processes, including crop production, construction materials, energy generation, including electricity and heat production, transport, wood products, chemical production, end-of-life processes, resource extraction, machinery, metal forming, metal products, etc. What I will be talking today is about the latest additions and updates that were made to the database during 2019-2020 and that were published in 2020. Just a very quick some words on the database structure, especially for newcomers. So the ecoinvent database is developed and maintained as multi-output, unallocated and linked uniprocesses, gate to gate. That's what we called the undefined database. This database, it's only accessible through the ecoquery, which is the portal that gives you access to the ecoinvent database in the ecoinvent website. Those uniprocesses here in the undefined database are created, are maintained in a form where they are the closest to the physical reality of the processes they are representing. What I mean is that they will have several co-products if of course this is appropriated for the process. They will list among the co-products the wastes that this activity will produce. The inputs will be listed as products and not unless the author decides to do so, and they will not be linked to the supply chain. They will just be listed as products. So if you want to check the original modeling under the activity, the choices that were taken by the author, the balances, the mass, the carbon, the water balances, the undefined database is the right place to go. Over or using that version, using that undefined database, we build 3 system models that you know by name, and probably more than by name: allocation cutoff by classification, allocation at the point of substitution, and substitution consequential long-term. To construct those 3 system models, we use distinct algorithms. And those algorithms are reflecting different modeling options. And what are those modeling options? The modeling options are the decisions that will be made in order to solve typical questions around LCI, like how do we solve co-production? What do we do when an activity is producing more than one product? How do we handle the burdens attributed to waste treatments? Or how do we handle recyclable products? Do we separate primary and secondary production? How do we calculate consumption mixes and technologies? How do we consider all technologies equally relevant in all scenarios? And those kind of questions are answered in those algorithms in a different way. And that's why each of them creates a different system model, which is then used in different contexts depending on the needs of your study. If you want to know more about the system models and about the methodology, you can find already some recorded webinars in our channel, and we will be also organizing in the next months more webinars around that. But today, what I will be talking more is about content, about ecoinvent 371 and 3.7, because let's take first a step back and let's talk about 3.7 before going to 3.7.1. 3.7 was released in September 2020. So 3.7 released more than 900 new datasets and updated around 1,000 datasets in the database, and it added around 100 new products to the database. In the 3.7, the coverage of the database was expanded in various sectors, so meaning that this update I just mentioned happened in the sectors listed here: metals, fertilizers, forestry and wood, packaging materials, waste, recycling, biogas, supply chains, and electricity market mixes. Then why are we talking about the 3.7.1? 3.7.1 was released in December 2020, and it was released because in order to correct a critical issue identified in 3.7. This issue was identified after the publication of 3.7. And as I mentioned before, we have an established and solid review process that goes on before accepting data for publication. And unfortunately, in this case, the issue slipped through the control process. It went undetected and was identified only after the release of 3.7. The issue relates to iron sinter production activities in Europe and the global version. They contained a mistake in the estimation of the emissions of particulate matter and dioxins. Because this data set is very central in the iron and steel supply chains, and because the iron and steel supply chains are very central in the database, the impacts of the error in terms of affected supply chains, to start with, was very big. We decided then to publish a new version, so a 3.7.1, and that's what I'm going to go now into details also regarding the relevance of or the changes in score that this correction causes in the database. Because we were publishing 3.7.1 in order to address this error, we decided also to update another dataset, which is zinc mine operation, global. In this case, the data providers, which is the International Zinc Association, communicated to us a needed update on the amount of the input from environment gold in ground. And that was communicated to us late for 3.7, but not late for 3.7.1. And we considered that this also would have a very beneficial impact in the new release. So, important thing, there is no new content. So there's no difference in terms of content between 3.7 and 3.7.1. What 3.7.1 has is a correction and an update, which is an improvement also. Important also to keep in mind that these changes that were done in 3.7.1 affect only some categories. The changes can be seen, and we are going into the details in the next slides. They affect the categories human toxicity, ecotoxicity, and mineral resources only. If you are working with other categories, climate change, water depletion, cumulative energy demand, land use, fossil depletion, acidification, eutrophication, ionizing radiation, etc., etc., the results remain unchanged between 3.7 and 3.7.1. So if you were using 3.6 and now you want to use the newer release of ecoinvent, we advise you to jump from 3.6 to 3.7.1 directly. If you were using 3.7 and you were working with categories that are not affected by the corrections we made between 3.7 and 3.7.1, you might keep on working with 3.7, knowing that 3.7.1 is an improvement of 3.7 in the end. But if you were working with 3.7 and you were interested in the categories that are listed here, human toxicity, ecotoxicity, or mineral resources, you should change to 3.7.1 because your results will change. And we are going to go to the details now in those slides. I will show you in a few slides here the comparison of results obtained with 3.7 or with 371 with a collection of indicators. We analyzed 272 indicators, and what I'm showing you are indicators, of course, that change. Those that don't change, I'm not going to represent them here. The whole analysis in all system models, because I will only be showing you cutoff. The other two system models, they follow the same tendency. The graphs are different, but the tendency is pretty much the same. But you can find the whole analysis in a technical report we published comparing 3.7 and 3.7.1, and also in the change report. I will be mentioning that later. So let's start with human health category. Human changes in this category are the most visible ones in the correction of 3.7.1 from 3.7. Here what we're looking, maybe let's explain that a bit better. I don't know if you can see my mouse very well. Let's take a laser. So what you can see here in the horizontal axis, we're looking at intervals of change in the results. And you can see 0, minus 10%, minus 10%, 20%. And what you can see in the vertical axis is the proportion of data sets that are affected by the change in the scores between 3.7 and 3.7.1. So because the correction that we did in the iron sinter production is affecting elementary exchanges that are important to calculate human health indicators and dioxins, this is something that is causing the changes here in the human health category. The most dramatic change happens with the ecological scarcity method under the indicator of carcinogenic substances into air. With this method and this indicator, yes, you can see here the impacts of around 60% of the datasets in the database are reduced by more than 90% if you compare 3.7 and 3.7.1. You can see impact 2002 plus also monitors the changes quite well at all levels. This is well distributed all over the database. Always 10% or 20% of the database changes in different intervals. And at the end, the correction is not having such a dramatic effect in other indicators from other methods. There's a second graph that you can see also in the technical report with other indicators that are behaving also like this, where you can see around 10% reduction of almost 80% of the database reduction in or increase in scores. It's quite a similar effect we see in the ecotoxicity category. The changes remain discrete and quite also homogeneous. As you can see here, there's almost 100% of the data sets in the database that will experience a 10% decrease in the scores, calculated with the indicators under the ecotoxicity category when you compare 3.7 and 3.7.1. Here in this slide, we are looking at the changes in results between 3.7 and 3.7.1 under the mineral resources category. And in this case, the origin of this change is the update on the gold intake of the zinc mine operation and dataset. As you can see here, most of the changes are pointing to reductions in scores between 10 and 40%. Between 3.7 and 3.7.1. The most dramatic reductions are observed when using the EF 2.0 method, and here we can go up to 90% reduction concerning 20% of the database. We were using 2.0, EF 2.0, not EF 3.0 in this calculation. A question that we got in the webinar yesterday is you will get similar results if you compare 3.6 and 3.7.1. The zinc mine operation that was released in 3.7 was not changed from 3.6 to 3.7. So this update in the zinc mine operation is benefiting also the results when you compare them with 3.6. As always, we published a change report. In this case, the change report is dedicated to 3.7 and 3.7.1 because, as I have mentioned, the content is the same. So if we scroll quickly in the table of content of the change report, you can see there's a whole first chapter, which is dedicated to the analysis of changes between 3.7 and 3.7.1. The rest relates to the content of the version, because as I have mentioned, the content in the end is the same, so they have a common report. You can access the change report here. I invite you to access it and to read it. It will give you a full picture of the 3.7 and 3.7.1 versions. And next to it, as I was mentioned, there's a technical report dedicated only to analyze the changes between 3.7 and 3.7.1. So let's dive a bit into the content update. So then from 3.6 to 3.7.1 then. And let's get started with the metal sector. As this the metal sector is affecting, so we were mentioning a large number of supply chains in the database, from machinery to electricity production. It's really one of the central sectors. So let's start with the updates made on cobalt, which were made with the collaboration of the Cobalt Institute. So in that case, the cobalt production has been updated completely. It will include now 4 new cobalt containing reference products, which are listed here. Those products, cobalt acetate, cobalt carbonate, cobalt hydroxide, and cobalt oxide, are co-produced together with the cobalt metal in the supply chain, in the different steps of the supply chain. The Cobalt Institute has also provided data to model the electricity mix, specific electricity mix for cobalt producers, similarly as we used to have, and we still have, for the aluminum producers. We also have now a specific cobalt electricity mix. And additionally, there has been some work on the cobalt supply chain to make it interact better with the copper and nickel supply chains. And this has been done first through the introduction of new, more specific byproducts that were then linking the cobalt supply chain with copper and nickel. And then it has been done by adjusting the production volumes of the different activities in order to construct markets that reflect the proper contributions of the different supply chains to the final market for the metal. Importantly, and this benefits all metals, I'm going to be also talking in the next slides, the prices for metals have been reevaluated and adjusted. As you know, in the ecoinvent database, there is the hierarchy of allocation respects very much the ISO standard. So we will prefer subdivision of the system when that's possible. Otherwise, we will use allocation with physical properties. So in that case, we use normally exergy, or we will use price as an allocation key. So this update of price is, of course, very important in the framework of the database. The metals I'm going to mention in this and the next slides have been updated by EMPA, the Swiss Federal Laboratories for Material Science and Technology, under a project funded by BAFU. So the main goal of the copper update was, in this case, to provide regionalized data that will better represent the local production conditions in the areas where the mining or the smelting of copper was taking place. So this has led to the addition of several new regions, or in the case of mining, for example, or the refinement of regions in the case of smelting, where we used to have very large regions and now we have specific countries. Another aspect of the update has been the separation of the smelting and the refining processes. And this allows now to model the two copper production routes, the pyro and the hydrometallurgical routes. And in general, similarly as I was mentioning before, there has been an overall restructuring of the supply chain involving renaming of flows and activities in the whole supply chain, also to harmonize them better with the industry convention, naming conventions. And the chain has been worked to improve connectivity with other metals. And with other metal value chains. Same as I was mentioning with cobalt, adjusting production volumes, making sure that market composition is really reflecting the contribution of the different technologies to the final market of for the metal. In the version 3.7 or for version 3.7 and 3.7.1, there is new data for mining and beneficiation and for smelting and refining of nickel concentrate. They have been introduced for the geographies of China and, of course, global. And that means that now there are two extraction routes in the database modeling different concentrations of nickel. 7 and 16%. And there's also a restructuring of the value chain, same harmonizing names and naming conventions with those of the industry, and then reworking production volumes of contributing activities, interlinking the different supply chains to reflect the reality of the suppliers of the metal in the end. There has been new data sets for rare earth production in China added to the database. As mentioning before, the price has been updated, and again, production volumes. In the 3.6 version, what you had available are rare earth oxide production from bastnasite ore, and now in version 3.7, the data sets, we represent the different extractions, rare earth oxide production from 3 distinct production routes in different regions of China, and to a lesser extent also globally. So you can find now a rare earth oxide production through the processing of bastnasite ore, bastnasite and monzonite ores, or ion adsorption clays. There has been also an addition of new beryllium hydroxide production, reflecting the mining and processing of bertrandite ore in the US. Beryllium hydroxide then it's an intermediate product, and it can be then used to produce beryllium oxide or beryllium alloys and the beryllium metal. And the new activities have been introduced for tungsten, including datasets for tungsten mine operation and beneficiation, datasets for intermediate products in the chain, and the datasets in that case are representing the different production technologies, so reflecting the technology mix that can be found in regions such as China, Europe, and the US. As I was saying, all those updates were covered by this work done by EMPA and funded by the BAFU. To finalize with the metal sector, there were updates made in iron and steel and aluminium. In the case of iron and steel, apart from the correction that we have mentioned just before, the iron supply chains have been updated. That was a collaboration with TU Graz, ETH Zurich, and also some internal work. In the end, we have updated the global and some European datasets for iron and steel production, from mining to steel making. Now the European supply of steel is modeled in more detail, going into some cases to the country level, representing some countries in Europe. And there have been some additions on the supply chain made to the database. Apart from this update of production activities of iron and steel, there has been big work done on the modeling of the disposal and recovery of iron and steel industry byproducts. So there has been an addition of a lot of those byproducts. So this has gained in granularity a lot. And apart from adding the new byproducts, it has also, the treatment chains have also been added. The recovery or the landfilling of those products have been added to the database. And to finalize with the sector, the version 3.7 and 3.7.1 is including now specific data related to the aluminium supply chain in Canada. This is data provided to us by the Aluminium Association of Canada through CIREC. And the update is covering the specific electricity mixes and also the production of and then the whole supply chain, from the production of anode and primary aluminium in Canada. This data is substituting the existing data for the region North America. So the remaining countries in North America are now included in our rest of the world region. Okay, I will then move to the second sector I wanted to mention this morning. This is the fertilizer sector. The changes in this sector will also have a large reach. We were mentioning the metal sector before, how it could reach a lot of supply chains. The fertilizer sector as well. This is, in the end, those are chemical substances that can affect, in some cases, the chemical sector, because they are precursors for other chemicals or other products. And of course, fertilizers also go to crop production. So they have quite a large impact. We have in the version 3.7 and 3.7.1 new and updated data on mineral fertilizers and precursors production. This is data from Yara International and Fertilizers Europe that came to ecoinvent through the World Food Database and Quantis. We also, or together with this update, we restructured and updated the value chains and the market mixes. What we have done is now ensuring a separation of the chemical manufacturing and the use of this chemical as a nutrient supplier. We have separated organic and mineral fertilizers, and we have ensured regional specific mixes for those fertilizers. And let's give first an idea of what has been updated. So you can find in the 3.7 and 3.7.1 versions updated or new data concerning the manufacturing of all the listed substances in the slide. When possible, when available, the data is regional, so you can find regional manufacturing data for a lot of the substances here. As you can see, some of those substances are precursors for other fertilizers, for example, like nitric acid or ammonia. Some are used also elsewhere than in the fertilizer manufacturing, in the chemical industry, nitric acid, ammonia themselves, but also, for example, urea. Urea is also impacting other results at other levels in the database. Urea relates to gluing agents, and then gluing agents are used elsewhere, like in the wood sector, for example. And then others of the substances listed here are fertilizers, and as such, they are used directly in the crop production datasets. Let's try to describe here what has been the remodeling and the advantages, or what it means to you as practitioner, this proposal on the fertilizer sector. A big part of the modification in the fertilizer sector, in the fertilizer value chains, is relating to this separation. I was talking before, a separation between manufacturing a chemical product and using it as a fertilizer, as a nutrient supplier, as a supplier of nutrient elements. Until now, the chemicals that were used as fertilizers were, since its manufacturing, named and treated as fertilizers. They were named and treated differently than other chemical substances. What we are making now is making the chemical substance independent from its potential use as fertilizer. And then we are harmonizing the chemical substance with the naming conventions and with the modeling rules of the chemical sector. You will find no more urea as N or nitrogen fertilizer as N being the byproduct of a chemical manufacturing process. And if we take the graph here, as we can follow ammonia as an example, being here on the top. As you can see here, it's ammonia is manufactured, is produced, and as such, from the market typically, or from the specific technology if wished. As always, this is free, is up to you, practitioner, to decide where your supply is coming from. But as such, as ammonia, it can be used in downstream chemical processes or directly as a nutrient supply for crops if wished. What we are modeling now is a connection to a generic market for inorganic nitrogen fertilizer by using this connecting activity. The same is done to all chemicals that have this use as fertilizer. You can see here as an example, a substance A. In the end, this is creating generic markets that are reflecting this one, that are reflecting the regional reality, because they will be regionalized. They will reflect the regional reality at the level of the consumption, the mixes that are made available to consume nitrogen fertilizer or phosphate or potassium fertilizer, of course, is valid for all nutrients. As I was saying, those markets are regionalized. They will reflect the reality of the different countries, and for that, we have used data from Fertilizers Europe mostly. What's interesting for you, or what can you do with that as a practitioner? So as a practitioner, you have different levels. You have the possibility of modeling the nutrient supply to your crop from a generic market, which then is giving you the regional specific average mix of a fertilizer or phosphorus fertilizer or potassium fertilizer. Or you can model the input of fertilizer directly from the connecting activity if you want to express it as a nitrogen fertilizer as N, or from the specific chemical if you wish to. All options are possible and depends on the level of detail that you want to ensure in your modeling, on the level of in an amount of information you yourself have for the modeling. You can choose the level of on the value chain that we have constructed here that suits your needs better. There's also, I have said it, and also we can see it here, there's a separation now, clear separation between inorganic and organic. We are only here showing inorganic fertilizer markets, but we have also done a similar work for organic ones. Let's look at what does it mean in terms of results, maybe. What we are seeing here is in the market composition for nitrogen fertilizer in version 3.6. We already had a generic product called nitrogen fertilizer as N in the version 3.6, but it was grouping, as you can see here, organic and mineral and inorganic fertilizers. 70% of the market was mineral, the rest was a mix of organic and organominerals. Also, the market was global. It only offered a global composition, only a single market composition for all. And the third, the generic market was not containing all the chemicals that can be used as nutrient in the crop production. Now, if we move to 3.7 and we look here, we are showing you some European markets. If we compare to 3.6, where light green in this case is representing all organic fertilizers, which are now excluded from the mineral mix, we can see how the country mixes can differ in the use of fertilizers and the European level, and how this is now captured. And of course, there's a similar effect when you look at other countries outside of Europe. Here I'm showing only big, important agricultural producers. And same, I'm comparing here with a version 3.6, which is in light green. And you can see how different the mixes are between those countries and how this is now captured by the database. Of course, those differences in the market mixes is then reflected in differences in the score as well. Here you can see I was until now using just nitrogen as an example, but here you can see the three nutrients, nitrogen, potassium, and phosphorus. And you can see that for each of them, there are generic markets present in all the regions, representing proper regional mix. And you can see how those different regional mixes result in different scores depending on the regions. We are comparing this with the unique global market present in version 3.6. Okay, so after presenting you the fertilizer sector, I would like to jump into the wood sector. This is an overall sector update that was done together with Werner Umwelt, and again funded by the BAFO, the Swiss Federal Office for the Environment. In that case is the whole supply chain from forest machinery, sowing and drying activities, planning, wood-based products, and wood preservation that was updated, adding new regional data sometimes to complete the coverage, and in general updating and refining the activities in the sector. There has been also quite some work that was put in adding new regional markets, in evaluating and correcting transport distances, in modeling imports at the European level, and in general in drawing better the European value chains. Concerning the engineered wood products, there has been some engineered wood products have been updated, like the ones listed here, removing in some cases the distinction indoor and outdoor, or also adding new glue producing activities. So glulam can now, for example, differentiate between the use of different adhesives in some regions. And just to connect this with the previous sector, the urea update is, of course, now benefiting also this update in the engineered wood activities. There has also been some new data sets and new products, new engineered wood products added. You can see them here: cross-laminated timber, structural timber, 3 and 5 layer board, and tubular particle board. As always, as we do every year, we have updated the attribution electricity market mixes. Now they represent the year 2017 for most countries. This is a work, the data creation and review was done in collaboration with ETH Zurich and PSI in Switzerland. In the case of US and Canada, the reference year is 2018. The US and ASC regions have been renamed and adjusted for the update, including the deletion of US SPP region, for example. In the paper on pulp sector, the updates and additions that have been made are all around packaging materials. So as you can see here, this is a piece of work that was done together with the industry associations Pro Carton, European Carton Makers Association, Eurosac and CEPI, and with the collaboration of RIS that was bringing the data into the database. So as you can see in the slide, there have been updates concerning solid bleach and unbleached board, white line chipboard carton and folding box board carton, craft paper, and we have added a new product, which is paper sack. Paper sack representing a hybrid mix of all types of multi-wall paper sacks produced in Europe. To go to finalize, and we are going slowly to the end of the webinar. In the version 3.7, we have added new data on recycling activities of packaging materials for Europe and Switzerland, covering the collection, the sorting, and the recycling processes of beverage cans and a paperboard. And in the 3.7 and the 3.7.1, you will find data sets related to biogas production and utilization. They have been updated or added new for Switzerland only. And now it means that in Switzerland, the biogas sector can be detailed into 4 levels: the biogas production, the purification, the biomethane injection into the natural gas grid, where it will meet the natural gas. They will meet in a mixed market. And finally, the biomethane upgrading into vehicle grade. Both updates are based on studies done by ETH Zurich and Carbotech, and also done some internal work. Finally, a small addition to the building and construction sector. There has been an updated version of glass wool mat datasets from Isove Saint-Gobain, Switzerland. This is an update done by Werner Umbelt. And the glass wool mat in Switzerland is now modeled with 2 alternative adhesives in the database. One based plant binder and the other phenolic binder. And with that, I would have finished my presentation. You have been very silent. I have had no question at all. We have some minutes, so I will wait some time to see if you were very attentive to what I was saying and didn't have time to type questions. So I propose that we wait some minutes to see if some questions come, and if not, we can end the webinar. So here you go. Okay, so how can we access ecoquery? So the ecoquery, you can access it through the ecoinvent website. If you go there, you can click on a login to the database or access to the database. That is already the ecoquery that opens to the ecoquery. What you can also do, if you wish, in the recordings of the YouTube channel, we have the previous webinars on 3.7. They had a dedicated part on how to navigate in ecoquery. You can go there. And otherwise, we're going to organize next month a whole webinar on how to access ecoquery, how to use the documents that ecoinvent prepares, how to access them, what are they, and yeah, how to use all the features that ecoinvent is preparing for you. Okay, I see things are flowing. Wait, I need to read and answer at the same time. It's not so easy. Okay, there are some questions related to the GHG protocol. So those I propose to answer them specifically, and also, otherwise we also have in the frequently asked questions some answers on how to use ecoinvent for the GHG protocol. So what? Okay. There are some questions also on electronics. There has not been an update on electronics for 3.7. We are working on it. And we really hope to have an updated or update the sector for the 3.8. I have another question on the zinc mine operation dataset. This is correcting the high gold resource depletion in this dataset, and then it will be reflected in a lot of other datasets in the database, of course. Yes. Okay, there are some questions also on the description or the meta information that can be found sometimes on the related to the electricity mixes. I guess it can relate to any other place where this can be read. When you read something like data have been extrapolated from the year X to the year X, it means that there has been some work of evaluating how much the data that was found from a specific year, how much these values were still reliable, acceptable, representative of in a following year. And after this evaluation, they were used in a data set which was representing eventually a different time period, for example. That's what these kind of comments normally mean. Okay, there are other questions which are a bit specific. I can answer them on email, more related to data. Okay, and yeah, there's a question on data sets that were transferred from ecoinvent version 2 to ecoinvent version 3, how this transfer was done and how that was adjusted. There are still some data sets from that were taken from version 2 into version 3. A lot of those have now, since the conversion, of course, disappeared or being updated, but some of them still remain. In the case when this conversion happened, uncertainty was recalculated, and the pedigree matrix values were reevaluated. So there was an evaluation or a work done on re-evaluating how the quality was expressed for those data sets. They contain not so much meta information. Some of them contain very little meta information when you compare them with data sets provided for version 3 specifically. But overall, that's yeah. Okay, thank you. I see people are already leaving, so I think it's maybe time to say goodbye. And yeah, someone is asking. Okay, well, I propose that I invite you to join the webinar next month on the features and documents on the ecoinvent and around the ecoinvent database. You will also be explained on details on the activity overview, which will help you finding details on the different data sets that are available in the database, including some details on whether they are new, updated, and yeah, the author, the year, time period, etc. So I invite you for next month's webinar, and I thank you all for your attention, for your questions, and I wish you a nice day, and goodbye.